Hi, this is Anshu, and this is a continuous session for the previous session where I was discussing some basics of probability. In this session, I'll go ahead and discuss the axioms of probability. What are the axioms of probability? Here, first axiom is probability of PA is always greater than or equal to 0, where A is some event, which is can be anything like tossing a coin or anything, whatever it is. So with this axiom, we will say that the probability of any event, occurrence of any event, is always greater than 0. That is, it is a non-negative, positive, real integer. Second is probability of PS is equal to 1. That means the probability of a sample space is always 1. The total probability of occurrence of event is 1. For example, if you toss a coin, so what is the sample space, head or tail? There are two events. Okay, so either this can occur or this can occur. So what will be the probability? PH, suppose, plus PT. What it will be? 1. That means occurrence of any event is a 50% chance for anything. What it is? The sum is 1. And the third is probability of A union B is equal to probability of A plus probability of B, provided A intersection B is equal to 5. That is, the events A and B are mutually exclusive. Now there is and this holds good only when your S is finite. Now, if we need to generalize this equation, how we will do that? So it is only for two sets. If we have, say, n number of sets, what we will say? Probability union I is equal to 1 and is equal to AI equal to summation I is equal to 1 to n probability of AI. That is sum of the probabilities of all the events. This is the generalization of this equation. But if in case the events which we have, they are not mutually exclusive, that means there are some common points between A and B. So what the equation will be? That is, A intersection B is not phi. A union B is equal to probability of A plus probability of B minus B. A intersection B. So, how we prove that? To prove this, we will again take help of a Venn diagram, and we will refer to the equation of A and A unit B that I defined in my previous session. So, what is A union B? It is referred to as A union A bar intersection B. And what is B? B is equal to A intersection B union A bar intersection B. Refer how I defined A in my previous session. So that time, what I defined for A. Now, using this equation and these two equations, we will prove. So, what you have to do is, this equation, take the probability and provide this and this are mutually exclusive. So what it will become? probability of A union B is equal to probability of A plus probability of A bar intersection B. Okay. Now again consider this equation, considering this and this are mutually exclusive events. So what it will become? Probability of B is equal to P intersection B plus P A bar intersection B. Now from this equation figure out what is intersection A bar intersection B. So what you will get is probability of A bar intersection B is equal to PB minus PA intersection B. Substitute this value of P, probability of A bar intersection B, in this equation. So what you will get is PA plus PB minus PA intersection B. This is when the events are not mutually exclusive. Now, this is just with two sets. If you have n sets, then what? So we have to generalize this equation as PA union B is equal to PA plus PB minus PA intersection B. How you will generalize it? Let's take probability. Let's say I is equal to 1 to infinite, 1 to n, so 1 to n, AI is equal to, from the first term we have this summation of the probabilities of A and B events. So here summation of probabilities of all the individual events. It will be summation I is equal to 1 to n E AI. Now from this equation, so we got these two terms as this. Now what about P intersection B? Here we have two sets, so we have just A intersection B. If you have three sets, you will get A intersection B, B intersection C, A intersection C, A intersection B intersection C. Similarly, if you have n elements, so that way it will go on increasing. So what you will get is minus summation I less than j and probability of AI intersection AJ. Okay. Now it's minus. Now you have a positive sign. Positive intersection with three elements. I less than j less than k. P AI intersection AJ intersection A plus so on plus. Now what? We have minus 1 to the whole power n minus 1. N is the total number of sets or total number of events minus 1. So based on that your minus sign will be used. Probability of A1 intersection A2 to intersection AN. This is the generalization of this equation for n sets. This was all about axioms of probability. Now, what remains is the two important two rules: conditional probability and the Bayes theorem. What is conditional probability? Conditional probability is denoted by probability of A, B. What it is? It is nothing but we are trying to figure out the probability of A and B has already occurred. Okay. What it is defined as probability of S divided by probability of B provided S belongs to B. Okay. And 0 otherwise, or you can say S belongs to B bar. So when you say that probability of A when B has already happened, that means the probability of A is going to lie in B but not in B bar. Now we know that how A is calculated. A is equal to, just like we have calculated for B. So A is A intersection B union A intersection B bar. Again, all these things can be proved using Venn diagram. Okay. Now take the probability of this. What you will get is probability of PA Now you need to figure out the probability of A when B has already occurred. So what it will be A when B has already occurred is equal to, consider S belongs to A intersection B and then S belongs to A intersection B bar. What it will be? Summation S belongs to A intersection B S plus summation S belongs to A intersection B bar, probability of S belongs to A. Here it's A intersection B bar, so we neglect this term. What remains is PS1B already occurred. So now what it is? PS1B has already occurred. Is referred to as P S divided by PB. S belongs to A intersection B. Now substitute S with A intersection B. So what you will get is P A when B has already occurred is equal to probability A intersection B divided by probability. Similarly, if you need to figure out probability of B when A has already occurred, reverse the terms P A intersection B and this B will be converted to A. This is called as a conditional probability. With the condition, now there is one multiplication rule used for A intersection B. Probability of A intersection B. What it is? It is defined by probability of B into probability of A when B has already occurred. Provided your probability of B is not equal to 0. Similarly, its probability of A dot probability of B when A has already occurred, provided PA greater than not equal to 0 and 0 in all other cases. This is called as a multiplication rule for A intersection B. Now we need to figure out that the events are independent or not. So when you say that A intersection B, okay, suppose we have P A when B has already occurred. If events are independent, that is the occurrence of B does not have any impact on occurrence of A. So then in that case we will get PA when B has occurred as probability. Okay. Now using this into the multiplication rule and for from conditional probability, what you will get is PA intersection B is equal to probability of A into probability that B and A is already occurred. What it is equal to is probability of B when is equal to probability of B into probability of A. This is how you prove independence of events. Now, this was all about conditional probability. Now, the last topic of this session, that is the Bayes theorem. What is Bayes theorem? Consider you have again two sets and you have n sets. So let B be an event. So we have B and B bar as two distinct sets. B bar. So now what it is? Now we have a sample space S with probability of B and probability of B bar as the probabilities of B and B bar. Take the probabilities. We have PB and we have B bar. We have sample space S. Now we know that probability A can be partitioned into two disjoint sets. Just as we proved some time back. What is A? A is nothing but union of A intersection B. Union of A intersection B bar. Okay. So if I take the probability of these two events, and by using axiom 3, what you will get is probability of A is equal to B A intersection B plus B A intersection B bar. Now, using the multiplication rule, what we will get is A intersection B is B A plus P plus A bar B bar dot B bar. Okay. Now this is how you take the probability of A. Now this was only with two sets. Now if we extend this relation to n number of sets, so what we will get is PA is equal to summation. Mind this. So B will be BI and A when B has already occurred will be BI or BA. Okay. So this is the extension to the n number of sets. So this is known as the total probability theorem. This is total probability theorem. Now using this theorem we will figure out how we calculate Bayes theorem. So now there are cases where event A is known to have occurred, but it's not known directly that out of this BI, which mutually exclusive event has occurred. So what we have to evaluate is BJ A. That one of the event BJ has occurs given A has already occurred. So we will use the definition of conditional probability and using this definition of total probability to calculate this. So from the conditional probability, what we will get is the intersection of BJ and A. BJ intersection A divided by probability of A. Now put this into this. So what you will get is probability of Bj is equal to probability of Bj intersection A divided by summation I is equal to 1 to n probability A and B I probability of I. Okay. This equation is referred to as Bayes precision or called as posterior probability. This is the method used as to create a Bayesian procedure. It is also referred to as Bayes rule. This is nothing but referred to as Bayes rule. I'll explain it once again. We have n number of disjoint sets, n number of exhaustive events, Bi to B1, B2 to Bn. We don't know that which of the exhaustive event has occurred. So let's say that we need to figure out the probability of Bj when A has already occurred. So using a conditional probability and this total probability theorem, we will calculate the probability of Bj when A has occurred. So what Bj when A, you will get probability of Bj intersection A divided by probability of A. This is using conditional probability theorem. Okay. Now using total probability theorem, we will put the value of A, PA. So this is your PA. So what you finally you got probability of Bj event that provided A has already occurred is equal to probability of Bj intersection A divided by summation probability of A when Bi has already occurred into probability of Bi. This is called as Bayes rule. So with this the session comes to an end. This was all about probability and basics of probability. If you have any doubts, I can be reached at my email address gupta.anshu3@gmail.com.